Hello everyone. Today I am going to present on the topic formal languages and syntax in programming. In this presentation, we will understand what formal languages are, why they are important, and how they are used in programming and compiler design. Introduction to formal languages. Formal languages are structured systems of symbols and rules that define how these symbols can be combined. They are foundational to programming language syntax design, providing the necessary framework for creating clear, unambiguous communication between humans and machines. So, a formal language is a set of strings formed using symbols and rules. So, these rules define how symbols can be combined. So, here, no ambiguity, unlike a natural language. So, example is in English sentence, I saw her duck. This is ambiguous. In programming language, int x is equals to 10 semicolon. So there is a clear meaning. This is used in programming languages, used in compiler design, and helps computers understand instructions easily. So what are formal languages? So a formal languages is a structured system of symbols governed by strict rules, that is grammar. So formal languages are structured systems of communication defined by specific rules and symbols. They play a critical role in the development of the programming languages, enabling precise syntax and analytics that facilitate programming and development of the code. So the components is alphabet, set of symbols, example AB, strings, combination of symbols, AB, AAB, BBA, and the third one is the language. It is a set of valid strings. Example, L is equals to A power n and B power n. Only strings that follows rules are valid one. So importance of syntax in programming languages. Syntax serves as the foundation for programming languages, dictating how statements are constructed and interpreted. A well-defined syntax enhances code readability and maintainability, allowing developers to write clear and efficient programs while also facilitating collaboration among team members. So, in importance of syntax in programming languages, syntax is rules of writing the code. Think of syntax like grammar in English. So, example, suppose int x is equals to 5 semicolon. This is the correct syntax. Int x is equal to 5. This is the wrong syntax because there is a no semicolon. In the programming language, rules must be important. So why the syntax matters means it ensures the correct structure, improves the readability, and avoids errors during compilation. So it helps the teamwork. Everyone follows the same rules. So without syntax, code becomes meaningless. So real life scenarios in the language structure in everyday life, natural languages have syntax rules. So it has a grammar rules. An example, subject plus verb plus object. And sign languages are visual grammar. So sign language uses visual grammar. So it has a structured hand movements. So next one is the mathematical notation is structured. It follows very strict rules. Example, 2 plus 3 into 4 is not equal to bracket of 2 in plus 3 bracket close into 4. It is not equal. So structure and rules are essential in all communication systems. So I have a case study. So designing a programming language syntax. So this timeline outlines the crucial stages in the creation of a programming language syntax. So highlighting key decisions and milestones. And here there are so many stages are there. So the first stage one is conceptualization. Here, we will define the purpose and the goals of the new programming languages, focusing on the targeting users and specific applications. So here what happens means we decide why the language is needed and focus on target users like students, developers, etc. And the purpose is like AI, web system programming, like that. Example, we have Python. So Python is easy for beginners. And the C language, it is a system level programming language. So this stage one conceptualization defines the goal of the language. And the next stage two, defining the grammar. So defining the grammar, it establishes the grammar rules that will govern the syntax, outlining how symbols will be combined to form valid statements. So grammar means it is a set of rules. So it defines how symbols combine and what is valid and invalid. So example, in we have the context free grammar. So S is the starting symbol. S use ASB slash epsilon. So grammar ensures correct syntax and used in parsing. And the stage three is creating an abstract syntax tree. So it is very important. So developing an abstract syntax tree to visually represent the structure of the code, and it will facilitating easier parsing and interpretation. So abstract syntax tree means a tree structure representing the code. So why abstract syntax tree is useful? Because it helps in the parsing and used in the compilers and removes unnecessary symbols. And the next stage four is syntax validation mechanism. So, so here it implements mechanisms for syntax validation to ensure user code others to the defined grammar rules. So preventing errors during the compilation. So it is the purpose because what is the purpose means here? Here checks it whether the code follows the grammar rules or not. And it will done by the parser in the compiler. So it compiles it. So it has the compiler detects the error and shows the message. And it prevents invalid programs from running. And the stage 5 is user testing and feedback. This is the main important. So conducting user testing to gather feedback on the syntax design, making iterative improvements based on user experience and usability. So after designing the language, we will test with the real users. So we can achieve the goals like improving usability, fix confusing syntax, and optimizing the performance. So languages are evolved. So this is the case study designing a programming language syntax. And the next one is key components of formal languages. Here, understanding the foundational elements that structure programming languages and their significance in syntax design. So the first one is the alphabets. Alphabet size. Here, the total number of distinct symbols and characters used in the format language, such as 26 in the English alphabet. So set of symbols. And the next one is grammar rules. Number of grammar rules that can be governed using a programming language, ensuring the correct syntax of the structure and defines a valid syntax, defines a valid structure. And the next one is 100% semantic clarity. Here, importance of the having clear semantics to ensure that every combination of symbols conveys a specific meaning. That means the meaning should be clear. So syntax is equals to structure and semantics means meaning. So this is the key components of formal languages. And the next one is applications of formal languages in compiler design. This is a very, very important in the formal languages. Here we will understand that the integral role formal languages play in the compiler development process. So, and the first one is lexical analysis. It breaks down source code into tokens using regular languages to identify keywords, operators, and identifiers. So formal languages are used in lexical analysis. The first one is the lexical analysis. Sorry, it breaks the code into tokens and uses regular expressions. And the second one is syntax analysis. It utilizes context-free grammars to parse the tokens and build a syntax tree, ensuring code structure follows defined rules. So it checks the grammar rules and builds the parse tree or the abstract syntax tree. And the next one is semantic analysis. Semantic analysis means it checks for the meaningful interpretation of code, ensuring that operations are valid within the language semantic rules. It checks the meaning. That means, example, int x is equals to hello. This is the type error. So this is the semantic analysis. And the next one is code generation and optimization. So optimization implements transformations on the intermediate representation to enhance performing while maintaining the correctness. So it makes the code faster. That's it. And the code generation converts the optimized intermediate representation into target mission code ensuring efficient translation of high level constructs. So this means it converts into mission code. So innovative examples of formal languages in technology is XML structures, data interchange. So JSON simplifies data format, regular expressions, and automate the tasks. So in the previous slide, I forgot to tell you that XML structures data interchange means extensible markup language. So it is used to store and transfer the data, and it has a string. It has a strict syntax rules. Tags must match. So it is a why it is a formal language because it follows a strict grammar and no ambiguity. And the JSON simplifies data format. It is a lightweight data format, easier than the XML, and it used in the web APIs and data exchange between the client and server. Regular expressions automate a task. Use it for pattern matching, and its applications are like form validation, and searching the test and the data filtering. So, formal languages are not just theory; they are used in real technologies every day. Now, in this slide, challenges in syntax design. First, it is the complexity versus usability. Designing programming language often involves finding a balance between complexity and usability. Languages with highly intricate syntax can offer powerful features, but they may also create steep learning curves for new developers. So conversely, simpler syntax can enhance accessibility, but might limit the expensiveness of the language. Striking this balance is crucial for promoting user adoption. So complexity versus usability. In the complexity, it has more features. That means the more powerful languages, but harder to learn. While in the usability, simple syntax, easy to learn. So, but may lack advanced features. Example, C++. Powerful but complex code structures, and Python simple but less low level control. And the next one is the flexibility versus strictness. Another significant challenge is balancing flexibility and strictness is in syntax design. A flexible language can accommodate various programming styles and paradigms, making it attractive to a broader audience. However, too much flexibility can lead to ambiguous code and hinder maintainability. It's essential to establish a structure that guides the programmer while allowing for creative solutions. So flexibility allow multiple ways to write the code, but it more freedom, and in the strictness enforces rules are strongly to follow. So it reduces the errors. Example, Java. Java is a strict typing. Python, it is a flexible typing. So here, good language design, good language design balances these trade-offs. The final conclusion and the future perspectives. The evaluation of formal languages is a pivotal in the advancement of a programming language. Yes, they enhance accessibility and power for developers. As we witness the rise of new technologies such as artificial intelligence and machine learning, formal languages will play an integral role in streamlining the syntax design and improving code efficiency. By simplifying complex structures, these languages foster innovation, making programming more initiative for the future generation. So, the role of formal language foundation of programming ensures clarity and correctness. Evaluation of technology, formal languages are improving with artificial intelligence, machine learning, and the future impact, easier programming languages, more automation, better code efficiency. So formal languages make programming structured, efficient, and understandable. So formal languages play a crucial role in programming and compiler design. They provide structure, remove ambiguity, and improve efficiency with advancements in AI and modern technologies. Formal languages will continue to evolve, making programming more powerful and accessible in the future. Thank you.